Hi, I'm Mason Hutchison, and I'm a design engineer for Scaled Composites in Mojave, California. I got my start in engineering by being curious about engineering, math, and science. But my career utilizes a lot more skills than just engineering, math, and science, and I'll tell you about the pathway that I took to get there. But first, let me tell you what an engineer does in the world of aviation today, specifically experimental aviation. Scaled Composites is a milestone experimental aircraft builder for many years now. They've built very historically significant airplanes such as Voyager, went around the world nonstop for the first time, unfueled, Spaceship One, the first private manned space flight, and many other milestone flights that have been enjoyed by the aviation community and technology in general. So what's it like working on the world's largest airplane? Well, a very large majority of our workforce are model airplane people, and it is that knowledge that we draw on. It's that knowledge that I had when I was 8 years old on how to build a model airplane that we're applying to building the world's largest airplane. So you got a big piece, it's just big, it's still an airplane piece, and it still goes on in the place that it goes on. That's just forward of the wing on the left-hand fuselage, and this is the day we were setting on this upper skin on top of the fuselage, and we see that piece and we know it needs to go up there, so we get a crane and we make that happen. The tail, let's put the stabilizers together, let's put the horizontal stabs on, let's put it on the vertical. It's all built as an assembly, and then that was lifted up and placed into place. And each person working on this has a specific job. There's a guy who sets the location. He uses a laser tracker and very delicately knows where that goes. And there's another guy that makes sure that the joint works out beautifully and perfect. And there's people that make sure that all the lifting equipment is safe. You know, as an engineer, I don't have time to make sure that the lifting straps are safe. Well, someone does that, and they do a good job of that. We kind of team together and make sure that each task is covered, but only by one person. We don't need multiple people to check those things. Here's a good picture. I like this. This is just once everything is kind of put together, to access this airplane, now we have to lift ourselves up to it everywhere we go. Here's standing on the wing for scale. There's a couple guys down at the bottom of the frame. That wing is huge. Like I said, it's a 1/4 acre of wing area, right around the neighborhood of a 1/4 acre. And it is one of the most impressive structures I've ever seen scaled build. It is largely bolted together, lots and lots of fasteners. Well, now we've got the 747 engine pylons and the engines. Well, on the 747, it has dihedral, and so it has a whole different set of mechanisms to lift that engine up to the airplane. We had to kind of modify those and make them work for us. We have no dihedral at this point in the airplane. How are we going to simulate this for the pilots? Well, let's start by building a homebrew simulator. Let's refine that a little bit more. So they made a fiberglass mold of the fuselage with the window frame in there. Now we have a dedicated simulator in the room, and it's got a big spherical screen, and the simulator is a fixed platform, but when you fly it with the cockpit from the other 747 in there and with all the flight crew, you actually, as you fly it, your sensation is that you are actually flying. It's weird. When I roll the airplane, I feel like I'm actually rolling. It's because of your sensory perception of that. But we have a fully functional, not a fully functional, but we have a highly functional simulator to teach emergency response, airplane handling, even taxiing. Every now and then we get a celebrity to stop by. Who's familiar with Bob Gerd, one of the original Imagineers? Anybody ever follow this guy? I love this guy. He highly inspired. We have this thing at Scaled called Lunch and Learns, and every now and then we get very highly accomplished people out to come give us their talk, their speech. And he showed up with his buddy Wally one day. That's a nice diversion. Of course, we get Burt Rutan from time to time. I think this is the only picture I could find with him. I think this is the day he found out we moved the tails. I think that's his "see, I told you so" look. We have fun. One time our chief engineer went on vacation, so the idea came up, let's fill his office with balloons. It was great until we figured out that all those balloons smelled like coffee breath. So let's talk about the wing. It's built thin for range, and it is straight for cost. You're building spars and ribs, and the idea there is that makes it a little easier to build. There are complications in that, but That made it much easier to build. Down at the bottom left is the Airbus A380 wing route. Down at the bottom right is the Hercules wing being moved through town. That's about a 15-foot wing route. Ours is 5 feet. Our wing thickness is 5 feet. It's not all that thick, and in the grand scheme of things, it's kind of a thin-looking wing. Oh, by the way, who's familiar with the torque, foot-pound, 1 pound hanging by a foot? The wing bending moment at the root on this airplane is equivalent to 1 male African elephant on an arm 1 mile long, if you can kind of think about that. I'm in the flight controls team, one of the many designers on it, and we use steel cables and pulleys and it's mechanically signaled. So when the pilot moves the yoke, it moves very small cables all the way out to the actuators at the actual surface and moves those. What's the hardest part of building this airplane? It's understanding how this is different from other airplanes. That is a constant thing we deal with every single day on this job. Moving the airplane is incredibly difficult. I love this picture. This is the day we first moved the airplane out, and just for a photo opportunity and a joke, someone grabbed a rope and pulled it. We couldn't figure out how to move the airplane out until the very last minute when we needed to move the airplane out. I'd like to point out the only guy in a not reflective safety jacket is our project manager, and he's pushing against everyone else. So that's just, I don't know if that's how project management sees themselves, but I thought that was funny. Moving the airplane, steering it on the ground, that is incredibly difficult because they don't make taxiways near as wide as runways, so there's a limitation there. And system complexity, it's a very complex airplane, and now that we've got 4 engines, or you got 4 engines in a 747, we've got 6. So marrying those systems together has been incredibly difficult. Here's a picture of the thrust levers, and I love these because they're very classically designed. And there's many other things like that. The absolute hardest part of this was growing the company while building this project. Here's a picture of White Knight 1 days, and that's the entire company under the airplane. And then White Knight 2, again, the entire company between the fuselage of the airplane. Now there's the entire company in front of Stratolaunch. So growing that, we're a little over 600 people. That is a very hard thing to do. We are engineers. We are not human resources or people type people, and so that has been a very huge learning curve for us, and if you can help us, that'd be great. Developing new technology, and that's just kind of figuring out how to move things from, yeah, this works and this is strong, to, uh-oh, that's huge, and how are we going to test it? At the bottom there is, you know, a wing test article. It was so big, just to test a section of the wing for loads, it had to have its own semi-trailer to move it, and that was an engineer's full-time job to figure that out. So what's next? We got to finish it. That's bigger than, you know, that saying, when you're 90% done, you're halfway there. We're there. Yep. Ground test. We test early and we test often, because when you test, you learn. I don't care how well developed your design is. Test, test, test. You will learn every single time you test. And of course, flight test. Recently, we taxied the airplane just before Christmas, and here's a video of it out on the runway, very slow. But it's under its own power. The engines are running and it's taxiing along on its own. And that is they're baby steps into getting this thing to work. You don't want to break things because that costs you delays and you got to fix it, and it's, you know, a little bit more money. Now we got to launch a rocket once we're there. Here's the concept that they're going for right now. It's 3 Pegasus rockets. A minute ago I showed you the L-1011 that had the Stargazer L-1011 that had the Pegasus underneath. This is 3 of them, so this is a potential for us. Launch 3 on one flight. Some more development on that coming. I started off as a curious kid building model airplanes and building other things that are mechanical or somehow creative in some way or another. And one of my favorite things to do is test those ideas by going out and giving them a try, and usually meant destroying something, but it also means learning something. After elementary school, in high school, I got not a job working at a regular job. I poked at jobs that required me to use my interest in aviation, which I became an airplane fueler at the local airport. I learned how to work on airplanes by offering to help the mechanic and be one of the guys that cleans airplanes. These are dirty jobs, but they're necessary in learning the ropes for getting into aviation and the aerospace world. After high school, I went to college at an engineering school and got my mechanical engineering degree. So I, did the traditional thing, got an engineering degree and got a job, because you got to do that. And so I figured I'd get a job the best I could to get something to build models. And the best I could figure out was something to build model rockets. So I did that for a while, and I got in trouble playing around with them, and so I had to get more serious. And so on the left is the true me. On the right is when the boss came in the room. And I've got a beautiful family. I'm your normal family man. That's us in the Hercules a couple years ago. But I just wanted to work at Scaled, and that's all I wanted to do. And I didn't have real aviation experience. I wasn't a commercial pilot. I wasn't a mechanic. I was just an engineer living in a land where I didn't have access to enough experience to get the job. So I built an airplane, made it as pretty as I could, just to send to Scaled and say, hey, I'm your guy. And that is the picture I sent 10 years ago to get the job, and I got it. So 1 year into the job, Horizon Hobby came by and shot a magazine ad for us, and we're actually in there with Bert Rutan and the whole bit. So my first task at that job, not having any experience whatsoever, was design the landing gear on this airplane. Are you kidding? That's incredibly hard. Who knows how to do that? I had no business doing that whatsoever. And after a couple years of hard labor, it worked. And this is a picture of Bert Rutan and I, standing by the nose gear of White Knight 2 the day of first flight. And science and engineering and math are what I call the perfect science. They have exact numbers often, or exact answers often, and they require many of the sharp skills to find the answer that you're looking for, as opposed to the creative arts such as writing and communication. But you cannot get anything that you have designed or built successfully installed until you have successfully communicated. So my most important message I can deliver to you is stay practiced in communication and keep learning. Aviation involves so many disciplines. You can get involved in electrical engineering, chemical engineering, mechanical engineering, computer engineering, all kinds of manufacturing engineering. Those types of disciplines are key to making a successful aircraft fly, and it's something that we use every day as a team of engineers and fabricators. The other thing that can benefit you in becoming an engineer is knowing how to use tools. Learn how to weld, learn how to rivet, learn how to use CNC, learn how to use a 3D printer, and learn how to build generically. Learn how to glue, learn how to finish. The most important thing that engineers need to know how to do is finish a project. So if you enjoy high detailed projects in building, engineering is for you. And it can be an extremely rewarding career. At Scaled Composites, we also enjoy the ability to do your personal projects. Many of the engineers that we have enjoy building things on their own. We have people who build boats, we have people who build their own airplanes, we have people who build models, and we have people who do things like build bicycles and engines and race cars. All those disciplines, anything that you can put your hands on and build, that is attractive to any engineering company and not just Scaled Composites. We look for people who are self-motivated and have the ability to identify a need in an engineering project and create not just a solution, but a creative solution that utilizes their own creativity and the capabilities of what's available to build. So stay focused and stay energetic towards things that include creativity and fabrication and engineering thought. Knowing engineering and knowing the science of designing and building things is a very valuable tool, but it's not the only thing you need to know to be a successful engineer. Everything else, including communication, is essential. And with that, I wish you luck and hope to see you in the future applying to Scaled Composites as an engineer. Thank you.